Well, so let's carry out some examples. Basically, what I'd like to do is as many examples along the lines of all the derivatives that we derived at the beginning of the course. In other words, in principle, you want to be able to integrate as many things as possible. We're going to start out with the integral of sine x dx. That's a function whose derivative is sine x. So what function would that be? Cosine x minus, right. It's negative cosine x. All right? So negative cosine x differentiated gives you sine x. So that is an antiderivative of sine, and it satisfies this property. So this function, capital G of x, equals negative cosine x, has the property that its derivative is sine x. On the other hand, if you differentiate a constant, you get 0. So this answer is what's called indefinite, because you can also add any constant here, and the same thing will be true. So C is constant. And as I said, the integral is called indefinite, so that's an explanation for this modifier in front of the integral. It's indefinite because we actually didn't specify a single function. We don't get a single answer. Whenever you take the antiderivative of something, it's ambiguous up to a constant. Next, let's do some other standard functions from our repertoire. We have the integral of x to the a dx, some power, the integral of a power. And if you think about it, what you should be differentiating is one power larger than that. But then you have to divide by 1 over a plus 1 in order that the differentiation be correct, right? So this just is the fact that d by dx of x to the a plus 1, or maybe I should even say it this way. Maybe I'll do it in differential notation. D of x to the a plus 1 is equal to a plus 1 x to the a dx. So if I divide that through by a plus 1, then I get the relation above. And because this is ambiguous up to a constant, it could be any additional constant added to that function. Now, the identity that I wrote down below is correct, but this one is not always correct. What's the exception? Yeah, a equals negative 1. So this one is okay for all a, but this one fails because we divided by 0 when a is equal to negative 1. So this is only true when a is not equal to negative 1. And in fact, of course, what's happening when a is equal to 0 is you're getting 0 when you differentiate the constant.